Hello, everyone. Welcome to February 2022 UJUG. So tonight we've got Venkat Subramaniam going to talking about the don'ts of functional programming and an interview and any questions that you have. So if you've got questions you want to ask, use the Ask a Question dialog at the bottom of your screen about there, and then people can vote on it. So this is a great way to share questions and know it's already been asked. So please use that. So I've got to go through some slides and we will get started. So we've been having fun with Crowdcast share dialogue. So let's see how it works for me. And I'll maximize that. Okay, everyone should see the beautiful UJUG logo at this point. So we're UJUG. These are the board members, and you can reach us at board@ujug.org. So if you have suggestions, requests, anything, please don't hesitate to call us. So Jason Porter, Jonathan Bronson, and myself, Don Bogardus. So let's continue. So these are our sponsors, Tech Systems. Kate is here, and I'll be talking to her shortly about the recruiting landscape. We always like to learn about what's going on, so we'll talk about that shortly. They're one of our diamond sponsors. Goldman Sachs, another diamond sponsor. They've been very involved and sent us a speaker like a year ago. It was great, low latency systems, how they do that. JFrog, we've got Ari Waller. He'll be talking shortly about just some interesting opportunities JFrog has. Lucid Software, another one of our sponsors. Overstock.com, Software Technology Group, and Applitools. And so let's go back to the JFrog logo, and I will bring Ari up, and he is going to talk about JFrog. It's all yours, Ari. Go ahead.
All right. Thank you so much, Don. Hi, everybody. Let me just go ahead and share my screen if I am able to. Let's see. Can we share at the same time, Don?
I'm not sure. Why don't you try it, and can you?
They told me no.
Okay, I'll close mine.
Okay, great.
There you go.
Awesome. Let me go ahead and
doing live debugging of Crowdcast share interface.
Yes, indeed. Okay. Hopefully everyone can see the slide that I'm sharing right now. Well, hi, everybody. My name is Ari Waller, and I'm the Meetup Event Manager for JFrog. Yes, it's a real job title, and I'm very blessed to have it. And we are really proud to be a UJUG Platinum sponsor for 2022. I'll just share just a little bit about who we are. JFrog is the DevOps software company. You may know us best by our flagship product, Artifactory, which was written in Java and is used daily by millions of developers and operations engineers across the globe. Besides the raffle that you can see up here, and I'll tell you about that in just a few moments, I also want all attendees to be aware that JFrog actually has a free cloud version of Artifactory and our JFrog platform, especially for the Java community. No credit cards required, and it's actually not a trial version. It's something that you can continue to use for your projects. You can use Artifactory as a single access point for all of your proprietary libraries, remote artifacts, and third-party resources. It also works seamlessly with Maven and Gradle. Also, if you are working with Docker, and I know many of you are, you can use Artifactory to manage Docker images, as it's capable of functioning as a pull-through cache for Docker Hub. And because of JFrog's partnership with Docker, you're going to be exempt from their rate limits on pulls from free or anonymous accounts. Now, tonight we have a raffle for a Nintendo Switch Lite. You can enter with the QR code or the bit.ly link that you see, and I'm also going to drop that in the chat shortly. A winner is going to be selected within 2 business days, and then we will share the name of the lucky winner with your whole community once the winner formally accepts the prize. All of those who enter, also, if you want to put your full address in there, I'm going to send you a T-shirt. So basically, there's a JFrog T-shirt, so there's really no losers. If you're here in attendance tonight and you want one of our awesome JFrog T-shirts, I believe it's Black Panther Frog, actually, who is appearing in the one I'm going to be sending out. So we'd love to be able to send that to you. So only if you want one of those, go ahead and put it in there. But we'll definitely get back to everyone with that. But we're very excited about being part of your community. Thanks Jason, Jonathan, and Don just for the awesome job that you do, and really excited to hear Venkat tonight. Thank you again. I'll drop those items in the chat, and I'll turn it back over to you, Don.
Great. Thank you very much, Ari. All right. So now I get to share my slides again. Let's see if I can figure out the share interface. There we go. Okay. So let me back up a little bit to click here, then arrow back to, okay, upcoming meeting. So next month, we've got Chris Mackey, the former president of UJUG, and he actually presented a great CD talk about microservices a year and a half ago. We're going to do a full interview session with him next month. So he's an expert on CD and consulting. He does a lot of consulting now for companies. So it's going to be a great interview about the modern or the state of the union with continuous delivery and continuous integration. So you won't want to miss that. This will be an hour and a half of just free-form questions that we'll ask, and then anything that the audience wants to ask. And then next month, we have Ian Robertson, who is a Java champion. You might remember him from several years ago. He had this, this blockbuster talk on API design and deprecation, and that was at Java 1, and he brought it to UJUG. It was great. He's the former chief architect of Overstock and a senior software developer at Amazon now. So he has some amazing experience with software architecture, and I'm really excited about this interview. Okay, and later this year, we've got Brian Sletton, Mark Richards, and Nate Shuda. We'll be coming out with those dates in the future, but I just want to get you excited about what's coming later in the year. Okay, so I'm going to back up to Tech Systems here and bring Kate up. And okay, Kate, can you hear me?
Yes, can you hear me, Don?
Yes, we can. Okay,
Perfect.
So I asked Kate to come on to talk about what's going on with the recruiting landscape. And so first off, let's start with the the big white elephant, or no, not the white elephant, the big elephant, not the white elephant, in the room as far as remote work. What's going on with remote work?
Yeah, so COVID definitely made people a lot more remote friendly. So you're seeing way more remote work than we did before the pandemic. I mean, I guess it's not technically over yet, but yeah. So I mean, there's kind of a mix of things. So you're seeing a lot of companies who actually went fully remote. I had an engineer tell me the other day that his company decided that they could save $25,000 a month on commercial space by just having everyone go 100% remote. So no more office space whatsoever for them. And you do see a few companies that are taking advantage of that. My office is actually one of them. We downsized. We didn't go totally remote, but we downsized by about half the space in our office to save some money. So that's kind of a cool trend. Then you've got your hybrids where people essentially have a choice. They want to do, some of them completely remote, some of them want to be on site some of the time, some of them want to be on site all the time. That's more like my company where some people are remote all the time and some people are in office all the time. And then you've got some companies who have just decided, hey, no matter what, we're going to stick with the policy of people have to be on site at least some of the time. Now, I will say I have yet to talk to one company lately that has to have their people on site 100% of the time. Before COVID, there were a lot of companies that did not allow remote work at all unless you had like an emergency or, maybe you had the cable guy coming. So like it was planned in advance, but it was not like something that they consistently offered. So yeah, I will say, I think nearly 100% of the industry that I'm seeing is that, that I'm seeing 100% is changed over to some manner of remote work. So even if they're saying you have to be on site, 3 days a week, they're at least offering a couple days.
Interesting.
Yeah.
Okay. So what's going on with salaries in the last year? What are you seeing? What trends?
Salaries are definitely going up. Where before COVID, my senior Java engineers were most often in Utah, somewhere in the range of like 125, 130. I had some, outliers of like my really stellar folks that I got into those companies that aren't afraid to pay that I could get in at like 140. I think I had maybe one person in at 150. Now 150 is kind of the norm. If you're a really solid senior Java engineer, I can pretty easily get you 150, 160. Got somebody an offer that total comp was around 240,000 the other day. So that is something I never would have seen before COVID.
Interesting.
I'm not saying it wasn't out there. I'm not saying it didn't happen, but it is not
was
something
rare.
I typically saw with my clients.
Okay. And then equity packages, is there a standard there, or is it pretty, variable across employers?
It's definitely pretty variable. I am seeing it more though. I do think that, I don't know if it's like the mortality thing with, COVID and people kind of thinking about their futures a lot more than they used to, but I do think it's more important to people than ever. So, where before COVID, it was like, salary. If they got an annual bonus, that was like, that's fine, but I don't really care that much. Equity was like, yeah, sure, that's fine, but really what matters to me is my salary. I think I'm hearing a lot more language right now of like, equity is super important to me. I want to be planning for my future. I want to know that I have some kind of stake in the company that I work for, and that it's going to create a future for me. And so we are seeing clients responding to that by trying to create equity offerings. A lot of clients that never had equity offerings in the past are now coming up with things here and there, not necessarily standard, but if they've got somebody they really want, somebody really senior, really killer, somebody that they really want to bring in, they're figuring out ways to make it happen.
Great. Okay. Is there anything else that you're telling people about the current landscape nowadays? Anything new and special?
Sure. I mean, it's very competitive. There are a ton of companies out there that are hiring. January, February usually is kind of a slower time, but we've got a ton open right now. I mean, I've got probably at least 30 Java positions I could talk to somebody about right this moment. That usually isn't the case this time of year. So that makes me really, really excited for that kind of segment of the year where we're typically the most busy, that like May to August kind of time frame. I think generally like the microservices stuff is getting to be like more and more common, where it was like, kind of the outliers. People were like, oh, it'd be really cool if they had this. Now it's kind of, it's sort of like, I think RESTful services started to be, it was like in the beginning when I first started this role like 5 years ago, people were like, ooh, if they have that, that would be really cool. And then it really became the standard. It was like, if you're a Java developer, you should know RESTful services at this point. And microservices is kind of getting to that point too, where everyone's like, yeah, we're really doing some containerization. We're using Docker, we're doing Kubernetes, we're pulling some DevOps into the mix. So that's all big. I think that trend of React taking over for Angular is definitely still continuing on that path. Trying to think of some others that I've been seeing out there. Yeah, I mean, generally, I think, people have been trying to tell me since I started this job that Java was going away. Nope, yeah. Java's not going away. Even if people want it to, it's just it's a big language, and it's kind of funny. I remember when I very first started this job, and people would tell me like Java's going away, like Go's going to overtake Java, or Node's going to overtake Java. There was always the thing that was going to overtake Java. Yeah. But there's so many companies out there that use it. They realize that the base of developers out there is biggest for Java. So when new companies come in, sometimes they're like, oh, let's use something really different and be out of the box. And sometimes they just go, yeah, no, we really want to have a nice big pool of fantastic developers to pull from. And so it just keeps going.
Yeah. Great. All right. Venkat, is there anything else as far as recruiting wise that has popped up in your brain with this conversation we're having that you want to add?
I'm like, I want to apply for a job now. I mean, hearing Kate, I'm like, gosh, can I apply for a job?
I can get you a job in a heartbeat.
It's very motivating to hear what you're saying. So definitely, it's very positive. It's a great time to be a developer, right? Both on the technology front and on the job front. So, I mean, let's hope that this continues in terms of the favorable market for the developers.
Absolutely. Yeah. And I mean, as always, those of you who have known me for a while know that I'm always happy to just talk. I am not a pushy recruiter. If you want to just call me and talk about who's hiring, what they're paying, just for your own information, like every single one of you, you're always welcome to call me.
Okay. And then Kate, why don't you drop your email in the chat for people that want to reach you?
You got it.
Okay, let's see. I will share the last of my slides. I promise everyone this is
and
the
I
last.
promised I was going to do some gift certificates too.
Oh,
so if
yeah.
we want to give a couple of $25 gift certificates away,
Okay.
We can definitely do that.
Okay, we'll do two $25 ones at the end. And everyone's automatically entered that's attended here. We'll just announce it at the end. Okay, let me bring back up my slides. Okay, so let's blast through to the end. So here's the door prizes. We've got 2 JetBrains licenses to give away, 1 Agile Learner subscription. This is Venkat's training site with a bunch of amazing videos that we'll talk more about later, but we give away a pass for this every month. And then the Tech Systems 2 $25 gift certificates for anywhere, right, Kate?
Yep.
Okay. So let me introduce tonight's speaker, Dr. Venkat Subramaniam, award-winning author, founder of Agile Developer, and adjunct faculty at the University of Houston. He's a co-author of multiple books, including the Jolt Productivity Award Practices of an Agile Developer, and his latest book, Pragmatic Scala, Creative, Expressive, Concise, and Scalable Applications, is available now. So tonight he's going to be talking about, we're going to do 2 sections. The first section is about 45 minutes of his talk of the don'ts of functional programming. And then the second half, the second 45 minutes will be an interview session. We have a few seed questions, but we'd really like to get questions from the crowd. And hopefully you'll be stimulated by a few of the questions that we ask and come up with your own to keep the conversation flowing. So once again, use that ask a question dialogue at the bottom of the page. So I'm going to point to it again. I guess I can't. I'll maximize my screen. And then it is down here about on your screen, says ask a question. Please enter your questions there. I will be curating those and throwing them into the conversation. So let's get it started. I will turn it over to Venkat, and I'm going to maximize your screen first, Venkat, and let me know when you're ready for me to maximize your slides.
I think we're good. Yeah, we're ready. Thank you.
Okay, your slides are maximized.
Awesome. Thank you so much. And I just realized that the bio that you had was quite obsolete. The Scala book was almost 10 years ago, so I don't know how that got through. The latest book actually is on Kotlin, but anyway, we'll talk more about this later on. But I want to talk about something that, when we talked about what talk do I want to give, this popped up in my mind because I've been working with a few different companies and a few different teams. And when I notice developers, programming, when they do really good things and when they do things that maybe need improvement, I always kind of make a note of some of those things. And that's what I want to really get to today in this particular presentation is the don'ts of the functional programming. And before we talk about the don'ts, let's talk a little bit about the practices. Well, there are good practices, and we could say there are better practices, but there are also poor practices that we often develop. As humans, I would say, for example, we have some really good practices. A lot of us and all of us do, but also we oftentimes have, poor practices as well. Some of us have mannerisms, some of us bite our nails, and it's really hard to even realize that we have those practices because once we start doing them, it becomes very natural. We don't even realize that we are, having those kinds of habits, if you will. When it comes to code, I would say that's actually even more true because a lot of times when developers write a poor quality code or have a bad practice, it's not that they have an intention to really write code with the poor quality or have a bad practice. They often do that because they don't even realize that they are doing something that shouldn't be done. And part of the reason for that really is that when they start doing some of those things, there's probably nobody to really point out and say, well, let's not do that. Or maybe that was not really heard. And so as they do it once and do it twice and do it third time, it becomes quite a bit of a habit. And so, but why should we really care about this? Well, the reason we want to care about this is if we don't really recognize poor practices and maybe put an effort to change it, the poor practices become our common practices. And then over the time, the code quality begins to suffer and the cost of development goes up. And then we, of course, complain about it. We say, my gosh, it's taking a lot of time and effort to modify this code. But then eventually we realize that this is cumulative in the long run, where a lot of things got together and made things worse. And so we want to really recognize some of these practices. In fact, when I pair with developers or when I sit down and write code with a team, showing how to do certain things, and I would ask them to show me certain examples of their evolving code, I would recognize certain things they do, which I really am appreciative of when I see them do really, nice things. But at the same time, I'll also, politely, where I can, point out and say, let's not do that. That's not a good practice. As an example, quite recently, I was, working with the team, and we were writing some code. And what I noticed very naturally was the following. A developer would say, some kind of an object, let's say instance dot, some kind of a function. And then the minute they put the lambda, very quickly and rapidly, their hand would do this. And I was absolutely intrigued by how so ingrained this practice was that they've been writing code in a certain way. And I was immediately pointing to them saying, let's slow down a little bit. There are some certain practices we are using here that may not be favorable, and we want to really think about it. So one of the reasons I want to really talk about poor practices is so we can recognize them and maybe we can try to change and improve on what we do. So what I want to spend in the next about maybe 20 to 30 minutes here is some things I've noticed and observed among developers, me included, by the way. I'm not here to tell you that this is what I've seen others do. This is what I've seen, a lot of people do, including myself. And over time, I'm, trying to recognize and make this better. And that's where I really, really, appreciate developers who work with me. And it's their turn to say, hey, Venkat, don't do this, or let's make this better. So we all collectively need to be improving what we do. So the first don't, and this talk is about what not to do, but of course, along the way, we'll encourage what's a better practice as well. So we'll talk about some of those things. The first thing I want to talk about is avoid single letter parameter names, except, of course, where it's absolutely obvious. So let's take a look at an example here. So suppose I have, let's say, a collection of strings. We'll call it names is equal to, let's say a list of, we'll say some names that I want to start with in here. So given these collection of names that I want to work with, I want to iterate and maybe want to print the names in uppercase, but only names of length, let's say 5. So quickly, I might be interested in saying names.stream, which is really a good thing, of course. Then I say filter. And what do I do now? And I say over here, x dot maybe length is equal to, and I'm going to say maybe a value of 5. And then I say filter, and then I'm going to say, or map rather, for example. So I could say, for example, arrow, and then I could say s dot to, uppercase, like so, for example. And then, of course, I may say for each, and then I could say, something, whatever that I want to print out, I might say something along these lines. I'm sure you have seen your share of developers who do coding like this. Now, the problem with this code is this becomes such a habit that we don't even realize what we are doing in here. But notice this variable name, for whatever reason, it seems to be a variable name called X, for example, or a variable name called S. Maybe the programmer was thinking, that's a string, so I'm going to call it as an S, or another variable, whatever that they may use, pick your choice of a variable name. The problem with this approach is that while it becomes really easy, in fact, kind of effortless to write this, it becomes incredibly difficult in the long run to understand and maintain the code. So there are a few things we want to really do when it comes to writing Lambda expressions. And the first thing is, unless it's completely obvious, like for example, an index variable like a I for iterating over a range of numbers, I would recommend giving a good name for parameters. I'm not suggesting giving a long name. That's not the goal. In fact, I was recently telling somebody long names are as bad as cryptic and short names. So the goal is not to give long names or short names, but to give meaningful names based on the domain. So for example, in this case, I would really appreciate if we said name and name.length. That makes it a lot more easier to understand what this is really about. And of course, I don't recommend putting a word string here because the type is not really important. What is important here is from the domain point of view, what is this really for? So I would rather give a name like so. Similarly, I could say name here and say name, and again come back here and I could say name and name like so. Now, of course, when we start writing code like this, where it is possible, rather than giving a cryptic name, if you're able to eliminate the lambda, that's even better. So for example, in this particular case, the code actually still works, but I could go here and remove the name entirely and say string to uppercase, and I could just convert it to a method reference. And like so in this particular case, I could convert this to a method reference as well. So if you're kind of tempted to give a bad name for a parameter, ask yourselves if there's a possibility to even remove that entirely and replace with a method reference. And where not possible, please do give a better name. And in all honesty, that takes only a little bit of effort, but once it becomes a practice, then it becomes natural for us to write code like that. And I'll share with you one story about this though. I kept reading about how beautiful the Ruby source code is. When I say source code, not the code written in Ruby, but the code for Ruby itself. It was written in C, and Marx, is considered to be a great programmer who created the Ruby language. So out of temptation one day, I went down and downloaded and started looking at the Ruby language source code. And I was in tears, by the way. And the reason is, as I was reading the code, the variable names were clear and descriptive, not long or short, but meaningful. And I kind of felt really humbled reading it. And I said to myself, even I can understand this code. The author of the language did not really say, hey, I know what I'm doing, you don't deserve to understand, but took the time to write the code in a way, even a non-developer of the language, I'm able to understand what he was doing in that particular situation. And I think that is something we should really work towards and give better names for these parameters in the long run. So avoid single letter parameters as much as possible. Once we get that into our habit, it becomes natural for us to write the code, and it becomes easier to express the code as well. The next thing, of course, I would say is avoid primitive types for parameters. So avoid providing types rather, type for parameters. So for example, sometimes people say, do I need to say a string and then a name like so? Do I need to provide that in here? Well, oftentimes what I notice people do again is they would do something like this. And this I think is not really a good idea, because we are relying on the type information more than the domain specific purpose and representation of that variable. So if you give me a choice between writing these in 3 different ways, if you will, and where I'm going to write it as this one here, and then finally I'm going to simply say this is going to simply be a name, which is the least noisy in here right now, I would say this one would be my preference in this particular case compared to this one, which I would not really care for, nor that one. So the reason for that is it's not really that important for me to know in this context that this is a string, because that's often obvious for me based on the surroundings and the knowledge of the domain. But what I really care about here is the fact is that's a name and not some kind of an X. So this is, I would say, the least desirable. And the next one after that would be this, but more ideally, I would say this is what I would prefer. So if you are tempted to give a type for a parameter, leverage the type inference. Now, when I talk to developers, when somebody uses one language predominantly, like for example Java, they're a little bit apprehensive in leveraging type inference. But when programmers program in a few different languages, maybe you program in Scala and Kotlin and Groovy and Python and Ruby and JavaScript and Java, well, you are a little bit more accommodative and willing to try out type inference compared to maybe programming only in Java. But it's again a matter of getting used to. So the more we start relying on type inference, our mind kind of rewires to say, I don't need to really specify the type everywhere. I can just focus on the domain specific name of that particular parameter, and then things begin to fall in place. So it's not really that difficult to understand the code as we move on, and it becomes very natural. So avoid single letter parameters. Don't provide the types, instead provide better domain specific names for those parameters. And of course, where that's not needed, use a method reference instead. One thing, if I may say most vehemently, is don't write a multi-line lambda. This is something I would say we need to really avoid as much as we can. And the reason I emphasize that is, this reminds me of an experience. I was teaching functional programming in Java in the UK. And when I went there, this was a Monday morning, and I said, hey, folks, I'm really glad to be here to teach a course on functional programming in Java. And one of the person raised the hand and said, well, welcome to our company, Venkat. So we all hate lambda expressions, he said. I said, well, that's pretty welcoming, but thank you. And I was talking about it. And in the middle of the course, I said, avoid writing multi-line lambdas. And I could hear a little bit of a commotion in the room. And then when I, gave them a tea break, and they immediately, one of the developers called me and said, come on over here, let me show you something. And I walked over, and he shows their source code. And he said, the person who introduced lambdas to our company wrote this code. And I'm not kidding with you. Almost every single lambda was 100 to 150 lines long. And I'm like, oh my gosh. And I was looking at it, and he said it gets only interesting. And they had a really good culture of writing automated tests. And the code coverage was the lowest in code where there were lambda expressions being used. So what I want to really say here is, if you are interested in writing a lambda expression, avoid putting a curly brace and then start writing multiple lines of code within that. So you probably have seen developers do this quite often, where they would put a curly brace like so, and then start writing multiple lines of code right there. And if we do this, we totally lost one of the benefits of using functional style of programming. And that is, the code is expressive. The code reads like the problem statement. But unfortunately, though, now when you look at a code like this, you look at this and say, what's going on? And you're trying to understand what's happening within this curlies, or at least trying to figure out where it starts and where it ends. And the code becomes horrible and really difficult to maintain. But what do we do if this is what we need to implement the logic? How are we going to implement it? So the first thing is, avoid multi-line lambdas. So if you really have a need to perform a multi-line lambda like so, my recommendation is, First of all, go ahead and write that as a separate method. Whether it's a static or not is irrelevant. If your lambda is being used from an object instance perspective, you can write an instance method rather than a static method as well. So in this case, I could say Boolean and check whatever based on your domain specific knowledge. You can give a name for that variable. And in this case, of course, I say string name. And then in this case, I'm going to take this code that we saw in here, and I'm going to move that up there, as you can see. So that's the code that we are interested in using in the filter, but I'm going to go ahead and move that here into this particular function. Then what you can do is to quietly come down here and simply say, hey, I want to perform that filter. So I can say check whatever, and I can send the name. So that's one option. And notice how the code becomes a lot easier to understand. Again, very little effort, right? It just indicates that we care to write good quality code. It's not that it took us an enormous amount of time and effort to do this. But the bonus is that the code is easier to understand. But not only that, the logic in this function now is easier to test. So we'll have a really good code coverage as well. But of course, as an additional step in this case, if we were to be able to extract that out, we can also, in this particular case, potentially take this one and simply say, I want to use a method reference rather than having to call that lambda. And so rather than having to write that lambda expression, we can route that using a method reference as well. So a small effort, but a huge benefit in terms of readability of code. So, and every time I read somebody's code, every time I am looking at a code when I'm doing a review or simply just working with a piece of code, anytime I see a developer has written the code where they take a parameter list of some sort, an arrow and a curly brace, and then they put some code around it, I immediately refactor it to remove that curly and then simply call a function. And that function is going to have the body of the code. A little bit of effort, but very, very powerful in the terms of the refactoring effort. So avoid multi-line lambdas as much as you can and just refactor the code, but also bring it as a practice to the team. I encourage your developers to say, hey, as a coding standard from now on, we will not write multi-line lambdas. And if you ever have an urge to write a multi-line lambda, call a friend and ask them to talk you out of it, or invite a person to pair with you. And also, as you're sitting and pairing with the developer, encourage them to say, hey, let's not do that. Let's refactor that. Let's put that into a function and then call that. And then it becomes a natural practice. And the team then does not end up writing messy code that becomes hard to understand and hard to maintain over time. The next thing I want to emphasize goes a little bit beyond the style of the code, and it's about avoiding shared mutability and impure lambdas. So when it comes to avoiding shared mutability and impure lambdas, one of the things we have to be careful about is if we perform mutability in our shared mutability in our functional pipeline, the code becomes incredibly hard to understand and reason. So let's look at an example of this just to entertain this thought right here. So I'm going to say here is numbers is equal to list of, let's say 1, 2, 3. This is Kotlin code I'm writing here to emphasize this particular case. I'm going to say numbers dot, and in this case, I'm going to say a map function. And in the map function, I'm going to say, if I am given a particular, number in here, I want to take the number and transform it into using a factor like so. So in this particular case, I'm going to use this particular factor, and then I will say a for each. And in this particular case, again, given a number, I want to simply print that particular number. So we'll say print line here and print it. Just for a moment, I'm going to say just a value of 2 right there and execute the code. So essentially, in this case, I'm saying print the value for me. And of course, 2, 4, and 6, that was pretty easy. But I'm going to say a factor right there. And I'm going to say a var factor is equal to 2. So when I run the code right there, you can see that in this particular case, the result is 2, 4, and a 6. So not a big deal, right? But let's go back to this code one more time. And I say val, let's say temp is equal to, I'm going to save that away. And I'm going to say temp dot for each. Let's run the code like so. But then what I would like to do in here, in this particular case, is right after we build this particular map, I'm going to say right there factor, let's say equal to 0, like so. So the question I would ask at this point is, what is going to be the result of this particular call? Is it going to be printing out a 2, 4, and a 6, or is it going to print out a value of 0, 0, and 0? And before you try to answer that question, you need to ask the question, how does the code actually behave semantically? So it turns out you probably have guessed in your mind, you said to yourself, possibly one of 3 responses. You probably said 0, 0, 0 is the output I'm expecting, or you said 2, 4, and 6 is what I expect, or a response I like to hear often is, I have no clue why in the world, would you do that, right? So in fact, I would use this as an interview question. And if a candidate tries to answer that question, I would say you're fired, right? So we want them to say, why in the world would you write the code like that? That's a terrible practice. Don't do it. Of course, out of curiosity, if you run that code, you can see what the output really is. And you can see that it's 2, 4, and 6 in this particular example. And you say, oh my gosh, it's 2, 4, and 6. How is that possible? Well, it turns out if I said as sequence over here, then the evaluation becomes lazy and the output is 0, 0, 0. So it depends on whether we are evaluating it lazily or if we're evaluating it eagerly, as you can see in this particular case. So, and the short answer is that requires really staring at this code. And do we really want to write code like this? Even worse, if this is being provided to you as a parameter and you don't know whether it's coming in as a sequence or not, then that code's behavior is going to be different depending on what's being sent to you. And of course, that's error-prone code. But what is the problem in this code? The problem in this code is this is a mutable variable, but that mutable variable is being used from within a lambda expression. So but that goes back to a discussion about what is an impure lambda. And I want to just mention that really quickly here about impurity. And I'm going to say there are 2. So what is a pure, a function or a pure lambda expression? Well, a pure function, a pure lambda expression, has no side effects. So that's the very first one. It has no side effects. But the second detail in this case is that it is actually idempotent. So every time you call it with the same input, you get the same output. But I want to emphasize one thing here is what does it mean to be pure? And I'm going to say there are 2 rules for purity. And developers often will know the first rule, but they don't think about the second rule as much. And it's really important for us to think about the second rule. The rule number 1 is a pure function does not modify any externally visible state. So that's the very first thing. It does not modify any externally visible state. That's the first rule. But the second rule is a pure function does not depend on any external state that may possibly change. So that is a very important rule to keep in mind. It doesn't depend on any external state that may possibly change. So if you look at this example, this lambda does not modify any external state. So according to rule number 1, that's great. But it's not one or the other, but both. But it fails on rule number 2 because it does have a reference to a factor which potentially may change. In fact, it does change over here, and that renders that particular lambda expression impure, and we want to avoid writing such lambda expressions. So avoid shared mutability and avoid impure lambda expressions as well. And I want to, in the next few minutes, quickly mention a couple of different things that we need to also keep in mind. And one of them is going back to code readability. So for example, let's say for a minute that I want to really take a collection of names as we saw in here. But what I would like to do here is to write code like this. I'm sure you have seen developers do this quite often. They write the code like this. And when you run the code, you can see it actually worked. So there was no problem with it. However, look at this code and compare that to this code right in here. It's exactly the same code, no difference at all, other than we put the dots vertically aligned rather than putting them on the same line. So I normally say, do this only if you really, I would say, really hate everyone that you work with. So this is a terrible piece of code because it takes a lot more effort to parse through and understand what's going on in that code. But on the other hand, when you write the code like this, you can quickly see the forest from the tree. Oh, given a collection of names, I'm filtering, mapping, and doing a for each. Okay, let me see what I'm filtering. Let me see what I am mapping. It gives you a high level detail before dragging you into the low level details. This one, on the other hand, says, I will put everything on your face and you deal with it. I don't care about readability, and I'm going to make it harder on you to understand the code. So once again, it doesn't take a whole lot of effort. In fact, you can configure your IDE. So when you write the code, it will start structuring that in this format. So avoid putting multiple dots on the same line and instead line up the dots vertically so it becomes easier to understand and easier to maintain the code as well. Again, a very small discipline, and it's a huge payback. The last two things are somewhat related, and I'm going to say, avoid fearing about performance. And I cannot tell you how many times, literally how many times, I see this every single time in discussions. People come to me and say, but what about performance? Oh my gosh, it's going to be slow. So don't really be fearful of performance. Almost invariably, we don't need that kind of raw performance. The functional style code and the imperative style code have almost the same computational complexity. So I tweeted about this not too long ago, and my tweet basically said the following. And that is, the end result of worrying about performance often is the worry and not the performance. So oftentimes when we say, oh my gosh, what about performance? We spend all that effort. And when we are done, unfortunately, what we are left with is not a better performance. What we are left with is all that effort and the worry that we went through. So if performance is really important, first of all, make it work, make it better. So get the code to work, first of all. And if the performance is adequate, then enjoy the more maintainable code. If the performance is not adequate, then profile the code and find where the problem is, the bottleneck is, and then address that, rather than trying to be fearful and write really bad code because we want better performance. And in the end, we don't have performance and we still have a code that is unmaintainable. But at the same time, however, don't assume that you know exactly what the performance really is. As we saw in this code, for example, if this code is evaluated lazily or eagerly? And the answer depends on three things: the library or the language you are using. And second thing is what kind of functions you are actually calling. And third is in what sequence you are calling them as well. So as a result, you want to really get a sense of, first of all, the correctness of the code, but also the semantics of the code as well. You need to be cognizant of, hey, is this evaluating lazily? Is it evaluating eagerly? So I can know how much work is being expended, not to squeeze out the raw performance from the code, but to be able to understand the consequence of what we are writing. But if we assume that the code is going to be poor in performance or better in performance, that doesn't really translate across programming languages, across libraries, across APIs, and then we end up really being misguided. So we shouldn't assume anything about performance or the execution, but to really understand the semantics so that we are able to go back and improve on it, knowing how this is going to be working behind the scene, depending on the language or the library that you're working with. And that leads to a much better experience to really benefit from these. So what I talked about here are a few different things we should avoid. But all of these things I've noticed, in real projects where developers are writing code that leads to either hard to maintain code or smelly code or hard to come back and evolve. And with having a little bit of a discipline, I think we can go a long way and eliminate some of these problems. And then it leads to a much better experience writing functional style code. And I hope you're able to help your own teams to improve on some of these things along the way by way of reviewing code and by pairing with them, and then politely indicating that there is a better way to write the code and steer them towards a better quality code, so it becomes overall better experience for us to write the code in our applications. So that's all I have. I'll be delighted to listen to your questions, your thoughts, your comments, and I hope that was useful. Thank you.
Thank you so much, Venkat. So just a reminder, please enter your questions in the Ask a Question dialog. And so you can ask questions about the presentation that we just watched or anything in general. We are now into the sacred AMA zone of the presentation, and I encourage to take advantage of having access to industry leader here for any question in this domain. I'm trying to think of things we don't want to talk about. We probably don't want to talk about cryptocurrency or anything silly like that. Right, Venkat?
I agree.
Okay. All right. So I've got a few questions to start things off. So tell me what you're excited about nowadays. Over the last year, since the last presentation, what kind of things have really fired your imagination? Are you excited about in this domain?
There are quite a few things that truly excite me, and one of them, honestly, things that I've been looking for a while, and I'm really looking forward to, is the benefits of using Project Loom. And Project Loom is, I'm hoping it's right around the corner. And what excites me about that is, in a way, right? We all look at these programming paradigms, and I'm a big fan of functional style of programming. But at the same time, though, I'm realizing that one of the biggest flaws of anybody would be to assume that there's one way to do anything. So there are times when we need to pick and choose a different approach. And there are times when imperative style is a better approach than functional style when your operations are predominantly impure. I mean, we just talked about why purity is important in functional style. Or if your code predominantly contains exception handling. Well, if you're going to be doing nested exception handling, doing that in functional style is incredibly difficult. Part of the reason for that is that exception handling is predominantly an imperative style of programming idea. It's not a functional programming concept. So where Project Loom really comes in is, if you really think about it, here's the way I would like to kind of approach it in terms of what it means to us. I'm going to say, if you ask me what is Streams API in Java 8, and I'm going to say Streams API in Java 8 is for the very first time, it gave us the ability to create a structure of a code where the structure of parallel functional style code is the same as the structure of sequential functional style code, which is amazing, because before the time of Streams, you write sequential code and then you change it to parallel, and it's a monster in front of you. You cannot recognize the origin of the code anymore. But with parallel streams, you can write the code sequentially in a functional style without much effort, keeping the structure the same. You can parallelize it. Now, I'm going to say Stream is to functional code as Lambda is to imperative style code. And what that really means is the structure of synchronous imperative style code is the same as a structure of asynchronous imperative style code. So in other words, in Project Loom, you write your imperative style code, which is running synchronously, and then you say, oh gosh, I'm calling into this microservice, I'm calling to this web service, I'm talking to this database. I don't need to run this synchronously. I want to make it asynchronous. Don't touch that code. Simply alter your threading model. You go from a normal thread to a virtual thread, and now the code, exact code you already had, rather than it being synchronous, is being asynchronous. So the structure of the code, which is imperative, can be synchronous versus asynchronous by simply a flip of a switch. Here I am, the structure of the code is the same, and I flipped the stream to parallel stream as a switch. When I wrote the book, I called it the master switch. So you're sitting there and saying, I flipped the switch, and this whole thing is going to be working differently. So that same switch here for synchronous versus asynchronous. So on one hand, you go sequential to parallel in the functional stream, and here you can go from synchronous to asynchronous with the same exact code. That's a huge benefit from the point of view of the effort to write the code and to maintain it. And that, to me, truly is exciting, is because I can leverage this. And knowing that we're moving to the world of microservices, we're moving to the world of asynchrony more and more. I hate to say this, I hate to admit it, right? That JavaScript got it right? JavaScript said, no multi-threading for you. We're going to only give you asynchrony. 20 years later, you look at that and say, my goodness, how could they be so correct? And now we are catching up to that paradigm. And in fact, that's kind of the trend we are noticing is finally we are realizing, we need to really accommodate a much easier way to do asynchronous programming. And I can't tell you how excited I am about what's coming up in Project Loom, just to be able to support that paradigm shift that we can really enjoy.
Wonderful. And I'm going to give you a shameless plug there. Where on your Agile Learner site, when do you expect to have a Project Loom course on there, or do you already have one?
Oh, you know what? I don't have one on that, but I've been
oh no, I tried to set you up there.
No worries. But I've been doing a lot of keynotes for companies, actually, because in all seriousness, that's been the hardest topic. And I talk to companies and they say, well, a lot of companies are doing internal conferences these days, and they're like, hey, what do you want to talk about? And I can't tell you how many companies have picked that particular topic as a keynote, because they're like, we want to ask our developers and architects to start thinking about it. So definitely that's been a hot topic in companies that are interested in moving their development team towards looking at the future. So and eventually, and one of the reasons I don't have it as a course really is that it's still not production ready. And that's one of the reasons why I would want to wait until that time. I hate to, it's one thing to say what do we want to think about, what we want to prepare, But a course in general is a lot more hands-on. In fact, it's kind of funny you asked that question, because this morning I just finished a course for a client on a parallel and concurrent processing, and it's a longer course. But the last section of the course literally was Project Loom, and I showed them, hey, it's not production ready, but that's what you can do. So yes, you can do all these multi-threading and complete with future, but keep an eye on where things are, even though you cannot use it. Well, plan for it as you move on. So that's kind of the stage we are in Project Loom. It's not production ready, but it's a good time to know what it is.
Great. All right, so we've got some questions. Thank you so much for those asking questions. Here we go. Robert Lee asks, I am now teaching computer programming in secondary education. I have several middle school students who insist on silly function names. Any suggestions on helping young people new to programming to appreciate well-written code?
Beautiful question. In fact, I couldn't agree more. This happened a few years ago. I absolutely relate to this. I teach at the university as well, but I was asked to go visit a university a few years ago, and I was doing a workshop for them. And I was walking around, and these are, college students, right? And I saw them write absolutely silly function names and variable names. I almost started, crying seeing this. It's like, my goodness, the faculty that you have don't care about what you're writing. And that's what brought you to this point where you're writing poor quality code and nobody told you not to do it. So what can we do? So I'll share with you my experience, what I've been doing. I've been teaching for about 30 years now at the University of Houston. I teach remotely. But every single day, I spend 3 hours on code review. And literally, I'm not even kidding. Exactly the code review I just did today is I take the code and I put a comment in there. I've automated a lot of stuff, and literally, it's exactly what we do in here, and basically to come back here and say, hey, you are writing this code, and I say, something along the lines of, a feedback, right? And then, please give, domain specific, specific names. And then I would say, what the particular name could be. For example, name instead of, X, for example. And it's something. The students are writing poor quality code not because they want to. It's because they don't have a sense that it's a poor quality, because they never told them that. Don, I'll relate to you one experience I will never forget in my life, right? And this is a silly example, but I'm 50 plus years old now, 53 years old now, and I'm telling you something from when I was 8 years old, right? This is the impact things have in your life. So when I was 8, I literally spat on the road. And the person who was next to me said, what'd you just do? And I kind of stared, and the person said, that's a really bad habit. You need to be mindful of your surrounding. That's not the way you do things. And I'll tell you, 40 years later, I remember that experience, because I did something stupid, not because I wanted to. It's because I didn't even realize that was a wrong thing to do, right? And I tell you, every single time I think of the first time somebody politely, privately told me, don't do that. And that made me a better person. And I think we can do that to anybody. Not everyone is going to change, but our goal is not to change the world, but the goal is to change the people who are willing to change based on our sphere of influence. So pairing with them and pointing and doing code reviews, right? And that's a commitment. I spend 3 hours a day reviewing code. Why? Because I want the next generation of programmers to be better people in our industry. That's a commitment we want to do. So by giving those kinds of feedback and saying, here's a better name to give. And you know what? 3 days later, they write a silly name, not because they want to. It's not clicked in yet. But I'll share with you one other experience. This is absolutely funny in my mind. I teach 2 courses. So a course on software design and a course on programming languages. And I was, and typically students take one course and then take the other course. And I do code reviews in both courses. And I was doing a code review for the programming languages course. And this was a student whose name I recognize because it's a familiar name. And I wrote a comment saying, I really like your code. It's beautiful. Look at the variable names, look at the function names, look at the functions which are not large. They follow a good, single responsibility principle, SLAP principle, and I appreciate the student during the code review. Well, the next day, the student had added more features, and I said, I really want to be sincere about it. I really like your code. I'm enjoying what I'm reading. Keep up your good work. And then I realized, wait, I recognize this name. The student has taken one of my other classes before. Well, because I use a version control, every single commit is in the version control. So I immediately went to the version control for the previous course, and I pulled up the very first assignment that the student worked on. And I'm looking through my comments. They were brutal, right? It was like, what are you doing? Don't give this variable name. Change it. Do this. Write this. And I'm looking at the student's code in 8-month period. And the code the student had written in January and the code the student is writing in September. And I'm looking at this and saying, not bad, right? That effort has paid off. It's not going to happen for everybody. But when you see that happen, you say, well, that was worth the effort because it takes the effort to repeatedly work with them, but the beauty is this, right? What I'm excited about is not the fact that the student started writing better code, but that multiplies now. Because when that student now goes and works with other people, that student says, we don't write code like that around here. And now you're having good practice multiply. It's contagious. So your influence is not limited to the people that you're helping. It's also helping the people that they touch as well. And as a community, I think we can broaden. So in short, what I would say is the next time you see something that is not good, don't be quiet, right? And again, goal is not to insult, but to really say, we don't write code like that. Let's write a code in a different way. And I think the great motivation is when they see that there's a better way to do, rather than just being told that's a bad way to do. I think we can improve that. And I've seen that happen among students. And that's what I always say. If you're among faculty who don't care about the quality of code you're writing, sorry, that's a missed opportunity because you don't even realize that it's a bad quality. And that's something I think we should really take the time to make better.
Very good. I love that. So before we move on, you mentioned 2 courses that you teach, I assume at the University of Houston, was that right?
Mm-hmm. Yeah.
Is it possible to audit those? Or are they only for enrolled students?
Yeah, they're only for enrolled students. In fact, this has been a bit of a battle, if you will, because over the past several years, the enrollment has gone up in the university. But unfortunately, the way I teach the course, because I do code review every single day, it's impossible to scale it. So I limit the class size to literally 30 students who work in pairs of 15 groups. This has been a constant discussion with the department. They would say, increase the enrollment. I'm like, I can't, because if I increase the enrollment, the quality goes down. So it doesn't actually make sense to audit it because the real essence of the course is not the content. In all honesty, Don, the students are actually listening to the videos on Agile Learner. I don't even teach anymore. So I give them links to the video and say, go watch it, but they learn by practicing. So they write code every day and I do code reviews every day. So it's a course where I've come to the belief that they're not going to become better programmers by listening to me speak. They're going to become better programmers by writing bad code and then refactoring it and then realizing how it is better. So the courses are by way of doing it. And then the students actually spend a lot of effort in the course because it's not a course where they wake up in the middle of the night the previous night and then push the code into the repository and be done with it. Well, they write code every single day and they rewrite the code every single day and they evolve it. So it's a course by practice, and so it doesn't scale beyond a small limit of the students. So I limit it to 30 students for that reason.
So do you think, are there any other resources online where people can get that kind of feedback loop? Where, I mean, there's certain sites like, HackerRank, where you can, it runs tests on your code to see if you've done it correctly. Is there anywhere else that people can get this feedback loop that you mentioned is so valuable?
I think there are a couple of ways in which we can definitely do that. One is, a number of people have been running things like mob programming, and that's a great way to get together as a group and start writing code and practicing it. The other is, I would say, this is something we can also do within companies where we realize the benefit of this and say, hey, why don't we start doing what I like to call as a tactical code review, right? A code review, not where you bring the team into a room, project the code on the screen. That becomes really emotional drain. But instead, one person writes the code, another person reviews it, and build a good camaraderie, and then start, reviewing code. Corey Haynes used to run code retreats. That's a great way, because you spend an entire day, 9 a.m. to 5 p.m. as a small group, and you are writing code and you are critiquing each other's code. In fact, that's something I would even say, once we are past this, time of pandemic, I would be delighted to come, work one day on a code retreat. And I've done this for a few user groups. For example, the Umeå user group in Sweden, I've run this there. I've done this for a few other user groups where we pick a Saturday, for example, 9 to 5, bring 20 developers, take a problem, and then we keep solving it over and over and critique it. That's a great way. So a lot of community effort exists to be able to do this.
Wow, that does sound amazing. Very good. All right, so we got another question here. Do you foresee of a time when Java is not popular anymore? Ooh, controversial.
I do. And I'm hoping I'll be retired by then. Well, so the answer is, it's not the question of if, it's a question of when. But if you ask me, what would knock Java off its current popularity? It's amazing to think about it, right? Two languages, Java and JavaScript, have done something no other language has done before. And that is, typically, there's, Bruce Tate is somebody that I admire. And Bruce Tate, if you look back in time, he wrote a book called, Bitter Java. That was one of the first books he wrote. And then his next book was Bitter EJB. And then his third book was Beyond, he wrote a Better, Faster, Lighter Java. And he's talking about things like Spring. Then his next book was Beyond Java. And then his book after that was Rails for Java Programmers. Well, of course, Bruce today spends a lot of time on Elixir, but it's interesting to watch him. And again, that he would be a great speaker to have at the UJUG as well. And Bruce is a great person to watch because he's a polyglot programmer. But one of the things he talks about is that the lifetime of a programming language typically is 10 years. And of course, when I say lifetime, immediately we can say, oh my gosh, are you silly? C++ is being used still and COBOL is being used. But the popular lifetime, right, when everybody is dying to go program in it, is about 10 years. Or companies are investing and hiring actively. Well, Java and JavaScript are quite the opposite. No other language has survived for more than 2 decades in the popularity scale for so long. And I mean, can you imagine in 2022, we're talking about JavaScript still, right? Well, I mean, something is wrong in the world, you could say. But the point is, it is so popular for this much long time. And so the question then is, what is there to knock these languages out of its popularity? And I would say it's not a language that's going to kill these languages. I think it's the environment that's going to kill these languages. And what I mean by that is, think about WebAssembly for a minute. WebAssembly is challenging the way that we are doing things right now. Because if I want to develop an application that runs securely on any system, and I'm not constrained to write code in JavaScript or in Java, we don't have a whole lot of answers. But WebAssembly is opening the door to make things very secure and polyglot and interoperable. So maybe in 5 years, we would be looking at a platform that is different from the JVM, and maybe WebAssembly is that platform. I don't know. So the question really is not what language is going to threaten any of these languages. It's what environment is going to do. And a lot of times languages never hurt other languages. It's been always either a business or an environment that really led to other languages' popularity. And I don't think ever we said, I want to pick one language over the other. It's always driven by something else. But the question then to ask is, what is that something else? Maybe it's WebAssembly. Java doesn't have an answer today for the browser front end. And so, but what could be that one that gives us the answer for consistently being able to do back-end development and front-end development with one language or a choice of languages? Maybe that would be WebAssembly. Or maybe the world of microservices puts a dent on it. We don't have to really tie ourselves to a language. I can write different tools and different compilers and different languages for building microservices. Maybe that's going to be the one that knocks it out of popularity. So it's not the question of if in my mind, but it's a question of when. But having said that, though, I would also say, especially for me, my desire is not for popularity of Java to end. I never wake up to wish for that, right? Because that's not the goal, but because Java has been evolving really well over the past several years. Jokingly, I say, there was a time I said Java was in its deathbed, and I think it was. But then suddenly you notice it's jogging out on the park and having a great time partying, and you're like, how did that happen? We were ready to sing its last rites, and suddenly it's jogging and having a party and enjoying it and being youthful. Well, credit goes to the developers behind the Java language. They've been putting a lot of effort to improve the language. So there's a lot going on for the language to be successful. But the reality is, I don't think anything is going to be successful for forever. And Java has been the most successful for such a long time. And so it's a question of when. And I'd be curious to know what actually makes the change. History will tell, I think.
Nice. So you mentioned WebAssembly a few times there. What are you seeing, in this ecosystem? What are you excited about there? And where is it actually making an impact? Where is it being used, today in production with good, where you feel it's a proper use for it?
Well, I think we are not there entirely, in my opinion, right? It's going to take a while. But Brian Sletton just published a book on WebAssembly, beautiful work. And he would be a better person to talk about this than I am, because he has invested so much research into it. My bet is maybe we're about 5 years away to see the benefits of it. We are still in the very early stages. There's a lot of promise, and there's a lot of advantages we see in not just the terms of the languages themselves, in the way of security models that we can bring in. Honestly, it really bothers me that we are running mission critical, economical, financial, business transactions on a browser that is running JavaScript. I don't sleep very well when I think of that, right? When I perform bank transactions, when I perform reservations, and it just bothers me, all that is running on something as fragile as that is. It's funny, because I would go to a particular site where I am either doing a financial transaction or a other business transaction, and see all these kinds of errors, and I'll just shake my head. It's like, how could we be doing serious business with technologies like this? And then again, my blame is not on the language itself, but it's the entire ecosystem is extremely fragile. And I think we cannot sustain this model. It's kind of like somebody was saying, right? If people are building houses with what we are building, commercial, applications, civilization would have ended a long time ago, I think.
no.
So that kind of scares me, right? So I think that the real reason we need something like this is we really need something that is more reliable and especially with the security itself is such a very important topic right now. And anything we can do to improve that, I think is well worth it.
Okay, so just so people have a good picture in their mind is what WebAssembly is, can you just crystallize it down to just the basics? If a technologist were to explain WebAssembly to a non-technologist, how would you explain it?
Think of it as a virtual machine that is totally polyglot, and it gives you fundamentally a very thorough interoperability with the host environment in a very secure way. So language is not a barrier. You can write C# code that runs on the front end if you want to, on a browser, for example. So it's a virtual environment that gives you a thorough integration with the host environment, and you can be polyglot about it. That's the way I look at it.
So where is this, virtual environment? Where is it running?
It's up to you. You can run it on the back end, you can run it on the front end, you can run it on devices because it's a virtual environment. So imagine this kind of like it's funny, right? Because I remember as a very young programmer looking at applets and saying, oh my gosh, look at this. I can run applets on my browser. Well, that kind of didn't materialize over time, and Java became popular on the server side. But imagine that same kind of ideas, but 30 years later, right? And so you can write in any language you want to, and you can deploy it in any host environment, but you're running it under that virtual environment. You can run that in a browser, you can run it on a server, you can run it on mobile devices, you can run it on IoT. I don't think there is a end to where it can run because it's a virtual environment that can be executed anywhere. And again, it can adapt to the environment and say, here are the things I need to bring forward in a very secure way, in a very authenticated way. So you have a very clear contract as to, hey, do I want to allow this execution for a particular environment with the user's permission and configuration? So it really opens the door for, you're not, in today's world, my language choices or my platform choices are my language choices. If I'm writing for the front end in the browser, I love a certain language, but I cannot use it because it doesn't run on the browser. On a back end, I love a language, but it's not the right tool for a backend. But why? Why should my language choice be restricted to the platform? Well, WebAssembly says, let's separate those two. Let's make that orthogonal. Your language choice doesn't have to be your platform choice. That to me is, again, as a programmer, that's exciting to me, in addition to the other benefits it provides as well.
Very good, very good. Okay, let's move on to our next question. From Richard Hall. Thanks, Venkat, for your presentation. Are some languages better at functional programming than others? What language would you suggest to get a good introduction to functional programming?
The answer is absolutely yes. And if you Google for it, you'll find this talk. And my talk is called Learning from Haskell. It's not learning Haskell, but learning from Haskell. I'm going to say I failed learning Haskell 2 times. And about the 3rd time, I said to myself, oh my gosh, this is so useful. I got to learn it. And to me, learning Haskell was a very fundamental change, because Haskell, being a very pure functional programming language, it's highway or my way kind of attitude with the Haskell. So it'll force you to think very differently. And I don't write production code in Haskell, but learning Haskell has made me a different programmer. I don't want to use the word better programmer, but a different programmer when it comes to writing functional code in JavaScript, functional code in Java, Kotlin, Groovy, Scala, even Python and Ruby. When I program in those languages, the influence of Haskell comes in. Now, there's a language called Elm, and ELM, and Elm is 99.9% Haskell syntax. The little part that I left out is F# syntax. So it's a Haskell plus a little bit of F# syntax, and Elm compiles down to JavaScript. And when because I knew a little bit of Haskell, I learned Elm. Elm fundamentally changed the way I think of writing JavaScript, because I'm sitting there and thinking, wow, this Elm code I'm writing is functionally pure, and it's a reactive UI language where your mouse move and keyboard interaction all reactive streams that come in as a data flow, and you are receiving this data and transforming the data. And then I sat there and thought about it and said, if I can do that in Haskell, when I sit down and write code in JavaScript, I can think more functionally and write code differently. So it's really motivated me to write JavaScript different because of the Elm influence. My Java is influenced by my Haskell influence. Again, Elm itself is influenced by Haskell. So I would say Haskell is a great language. It's not an easy journey. Oh, by the way, Pragmatic Programmers just published a book on Haskell this week, so it's worth looking at it as well. And so it's really a nice way to dip your toes into it and start experimenting. But I would say, learn by writing code in it. And I always say, if a language you are learning is not helping you to kick and scream and cry, you have not chosen the right language. Because to me, a fundamental purpose of choosing a language to learn is that it changes the way we think about it. And Haskell did that for me. A few years ago, before that, I spent the time learning Erlang, and that was very helpful as well, because Erlang is also a functional programming language. But the difference is Erlang is dynamically typed, Haskell is statically typed. So if you have a more of an inclination towards a static typing language, I would say go the Haskell route. If you're more inclined towards dynamic type language, go towards Elm. And I usually say Elixir is child of Elm. Elixir is a child of Erlang and Ruby. So you can kind of see that flavor come through as well. And that's another advantage you get is once you learn some of these languages, it becomes easier to pick up these other languages along the way. So I would say Haskell, Erlang are really a good starting point.
Excellent. So along these lines, I wanted to ask about Scala 3, and specifically what is attempting to be accomplished in Scala 3. It's a major change, and do you feel like that success has been reached toward that goal?
Scala is a language which boldly, courageously innovates, right? And over the existence of the language, we've seen this consistently. When I talk to programmers who use Scala, they love the language for its capabilities, whether it's a functional capability or the type system in the language. These are really good things. But unfortunately, though, over the years, and this is nature of innovation, right? One of the things we have learned as developers over the time is we don't sit down and create a solution and walk away. We create a solution and we come back and say, now that we have done this, what can we do to improve, right? As an example, I heard Stuart Holloway, the group of folks behind Datomic, which is a database, immutable database behind Clojure. Stuart Holloway said they rewrote Datomic from the ground up 5 times over. I mean, imagine that for a minute, right? Do somebody have the courage to start over? Even the second time is enormous effort to ask for, 5 times over. And one of the reasons he said that they did that is they learned so much having done that a few times, and they come back and redo it and make it better. And look at Angular, right? Why do we have an Angular, whatever version we have right now, compared to Angular 1.0? Well, lessons were learned in what was created. Well, let's be open and admit it. We as humans cannot create something correctly in one sitting, or even in the second sitting, or the third sitting. And Scala has gone through that. The only languages that are going to be stable are the ones that don't innovate. And then they become obsolete because they don't innovate. So Scala is a language of innovation. But the result of that innovation is that there are a lot of rough edges. And when you start using those in Scala 2, you feel the pain of those rough edges. And what happens is when you have a group of developers who are the passionate developers behind the language, users of the language, they don't complain about it, they embrace it. But then you have these other people who get exposed to this and they start kicking and screaming because it doesn't work the way they want it to work. And that really gets a bad name for the language because, hey, this is not what I expected. Why do you make this so complex? So Scala 3 is really a major cleanup and overhaul of that. So the language has been cleaned up. So it gives you the power of that innovation, but in a way that you can reap the benefit, but without a lot of those ideas getting in your way. So type system is great, but the type system is on your face, you begin to struggle with it. So what if the type system goes behind the scene and you can do inference more, productively? Then it becomes a natural way of writing the code in the language. So I have the deepest respect for such innovation. And that's what you're seeing in the language is an innovation, but a cleanup after the innovation to say, here's all the things we have done, and here's what we have learned from that experience. Now let's come back and refactor that and make it better. And I think that's a right thing to do. And the funny thing is, most languages don't have the ability to do that, right? And hats off to the Scala community to come back and say, no, we are going to make it better, even if that means that it's not going to be backward compatible. And we're going to provide you the transition path from where you are to where you want to go, but this is the greater good for where we want to be in the future. So that's a cost of innovation. And we can be in denial about it, or we can embrace it. And I'm really happy when a group of people can be courageous enough to embrace that and have the ability to move forward with it.
Very good, very good. Shifting gears, I want to make sure we don't miss talking about the Dev.Next conference. This is a conference that you've been dreaming about for a while and just had the misfortune of the inaugural event happening in March 2020, just as things were closing down. And I often think about your thought process as things were happening. In February and in March, I was like, oh no, Venkat's conference is coming up. And so when we talked last, you had some dates in mind. What are your latest thoughts for the conference?
So we have scheduled that. I can't tell you how many times up to this point. And, things are going to get better in 3 months. Things are going to get better in 6 months. And we did schedule it quite a number of times. And unfortunately, though, the last time we scheduled it, we took a fairly huge financial loss on it, actually. And, the hotel said, hey, sorry, we can't keep doing this anymore. And so we had to pay a huge penalty. We got out of the contract after paying the penalty. So the biggest risk right now, a well-established conference has a much better experience doing this than a beginner conference like the one we are trying to do. So what we decided to do was to kind of ease off from that for the year, because in fact, the conference was supposed to take place about 2 or 3 weeks from now. That was the date we had settled on. But looking at where things are, I don't think 2 or 3 weeks from now would have been a good time. Even fairly well-established conferences have pushed it to April and beyond at this time, whereas we were trying to really do this in November, and then we pushed it to March. And come November, we were getting a pulse of it's like, March doesn't seem to be the right thing. So we decided to just postpone it till 2023. So or even beyond, right? We really want to. So I've come to the point where, rather than trying to predict the situation, let things settle down. And it's been too frustrating, emotionally, but it's been too frustrating financially as well. And I've kind of learned the lessons. That let's wait. Let's kind of let things settle down. And we want to do a good job, and we want to really do what's right for the community. and there's no timeline for that, so we don't need to be rushing for it. So we decided to wait until maybe 23, and if things are not really prime at the time, maybe 24. But we'll just have to wait and see.
Okay. So along those lines, what other just general life lessons have you learned during the pandemic?
Quite a number of them. This has been a period where there is so much of things that you think you know that you realize that you didn't. One of the very first things was a wake up financially, if you will. And what I mean by that is the reason to create emergency fund, right? And I know this, and I've done this over the time, but over the years, you're like, oh, we need money for this, we need money for that. Or maybe I should really rethink about building a better emergency fund. Been working on that. The need to be supportive of the people, not just your relatives and friends, but just as a community as well. So one of the things I did during the pandemic was, being literally this area here is where I live. And my day starts about 2 a.m. these days, because I've got clients in Asia and Europe, and I'm teaching courses at 2:30 in the morning. So in fact, today is not a good day to talk about, because I did an O'Reilly class for the Asia Pacific region from 9:30 p.m. to 1:30 a.m. And then I switched over from 3:30 a.m. to 8 a.m. for an Asia client. So I was doing an all-nighter last night. But that's something I've learned, right? Because you're on a Zoom, I can go from Austin to Australia in 30 seconds. And I thought I was busy before, but I'm busier now, right? Because my day starts at 2 a.m. and I run till about 9 p.m. typically every day now. So that's been pretty taxing as well. But one of the things I realized is, we're all stuck in some place. And one of the lessons I learned was to really be part of the community in a place where you cannot be physically part of a community. So one of the things I did in 2021 was I created what's called a PAL, a PAL session, where PAL stood for Pair and Learn. So I opened up my calendar, and every week I would pair with somebody from around the world for 2 hours every week. And it's been an amazing experience, a learning experience for me and for the other person as well. This person I don't know, but we connect, we talk about a technical problem, and then we solve a problem for 2 hours. And it's been a rewarding experience, and I called it PAL. I documented that on my website. The other thing that I realized is that to really be supportive of people during this time. One thing we tend to forget is, I'm very privileged. I don't have little kids in the house running around. I have a family that's very supportive of what I do. So literally I have this space, and I can be here and teach at 2 a.m. and don't have to worry about bothering anybody or bothering a neighbor. But then I realize a lot of people don't have that kind of luxury. They are in an apartment, they don't have a facility, they don't have a proper internet connection. And it's kind of silly for us to think that everybody should do something the way that we think they should do. So if at all anything, this time has given me the opportunity to become more empathetic, and to start thinking a little bit more about not just my life, but the life of others. What is it that they may not have, and how can we be accommodative of them? When I listen to maybe managers who say, well, every employee should do this, I'm like, no, you can't say that, because you don't know. You may be in a position of privilege, as I am, but a lot of other people are not. I'll share with you this one experience I would never forget. I was teaching a course for a client, and most of them had the videos off. And when I finished the class, one of the gentlemen in the course said, "I've got a question for you. Can you help me with the problem I'm having?" I said, "Absolutely, I'll be delighted to." And he said, "Hang on a second, let me turn on my video." And he turns on the video, and for the first time I'm seeing him, and I see him literally with an infant on his lap. And then he is, typing with one hand. And I said, "Oh, you got an infant with you?" He said, "Yeah, we had this baby not too long ago, but I'm it's my time to take care of the child while I am trying to get this work done." And that just blew my mind, right? Is that we assume a lot of stuff. We are not really working from home, as somebody said. We are literally living at work. And so when I'm teaching, we got kids running around, we got pets running around. The other day I was teaching a class, and absolutely the cutest cat ever climbs up on the top of the shoulder of this lady and is like curiously looking at the monitor. I said, "I'm sorry, but how could I teach when your cat is so cute and staring at the screen?" But to me, that is really life right there. And I'm becoming more appreciative of life more than just getting work done. And so many different aspects that this time has taught me. And I wish these lessons could have been learned without all the suffering the world had to go through. But nevertheless, I think that's been a great learning experience in so many different fronts.
Very good. Very good. All right. We're over time, but we've got a few more questions that I'd like to blast through so everyone gets their questions answered. So let's start with this question from Manoj. Kotlin has an it variable by default in lambdas. How do you see that? How do you see that in the context of meaningful name?
Yep, I don't use it. That's a good point. I don't. In fact, I consider it to be a bit insulting, especially if that was a person, the people collection you are dealing with. I actually make a joke of it when I teach. If I have a collection of people, I would not dare to put an it on it, right? So yeah, you're absolutely right. I think these are, by the way, that it variable comes from Groovy into Kotlin, and that's exactly what I say. Is I'm not a fan of using it in Groovy nor in Kotlin. I try not to use it. So I would say I would choose a better name than it in general when I write code.
Very good, very good. Okay, next question. I'm planning to start teaching Java in my native language, as none exists on the web as of today. Where do you think I should start for complete beginners? I don't want to get lost in a topic of explaining how computers work before I help them print "Hello World" on the console. I would appreciate any suggestion.
I would say if you're able to find nice little game, and when I say game, I'm not talking about like video games, right? But like Wordle, for example, there is some game. If you can ask the students to build that game, I think that's very motivating, because you are building something tangible. So rather than saying, let's create a stack and iterate over a list of objects, that's so bore and dull, but let's create an application. And as they're creating the application, they discover these data structures, they discover these concepts. I think that's a better way to learn, because there's a purpose to create something, and they're getting exposed to these concepts. None of my children are programmers, but they had to do programming as part of their course in school. And when they built the application, my elder son actually built a little game where you shoot down on monsters, and he entirely built this by himself. And I just coached him on what a function is and what a test is, and then see him build it. My second son literally learned C++ and built a tool that controls a prosthetic arm, and all written in C++. I mean, these are kids with no experience programming, building something you can actually use. But what really brought them to that point was, if I had gone to them and said, let me teach you data structures, they would have run screaming. But instead, they built something tangible, like a prosthetic arm or a game shooting down aliens, that gave them a purpose to build. And along the way, they discovered data structures and algorithms and functions and things. I think that's a better way to learn, is to have them build something. And then by way of doing that, you're kind of teasing them towards concepts they need to learn, by way of building it.
That's some like Mr. Miyagi technique of teaching there from Karate Kid. Just like you put things in their brain without them realizing it. All right, next question. What are your thoughts on Erlang VM and languages such as Elixir / Phoenix as the next trend in full stack app development?
I think definitely we need to pay attention to those languages. I think those languages are really giving us a different set of tools than what we are used to in a traditional conventional way. Erlang itself is such a proven technology. Companies like Ericsson have used them mainly for their reliability, right? I mean, the mean time between failure is so, amazing that we can learn a great deal to build reliable systems from them. And Elixir itself as a language and the related tools have learned some of those experiences, and it brings the fluency of programming as well. In the programming languages course I teach, students often bring these languages by themselves and say, hey, look, we want to program in this. And the speed at which they're able to learn these languages is pretty amazing as well. So definitely, will those languages replace the traditional world? I don't think so, right? So they're not going to be, I don't think any language that I see today is going to be that one that replaces things. But I think by using them, we can do better development. But by learning them also, we can come back and do better development with the tools that we already use as well. I think we get benefits on both ends.
Very good. All right, next question. This one from Jack. Java has made strides in supporting functional programming, but is behind when compared to other languages like Scala. Are there functional libraries that you would recommend to fill gaps until Java catches up fully?
So I look at it in a different light than that, because if you really think about it, the innovation of Java is clearly not in Lambda expressions. We can all agree with that, because Lambdas have been around for 40, 50 years now, so it's not new at all. But the innovation of Java truly is that when Java introduced Lambdas, the biggest innovation was not Lambdas, in my opinion. The biggest innovation was Invoke Dynamic. And Invoke Dynamic gave an opportunity for us to implement the Lambda expressions in a very efficient way. Now, Scala decided to change from anonymous inner classes to use Invoke Dynamic. So the power of the Java is not the language, it's raising the bar of the ecosystem. And you can definitely start using other libraries where you find a need for, but I think the Java language itself gives you fundamentally the things you need to be effective. And at that point, it's a question of saying, hey, do I want to really bring in other things? Maybe one area where you can benefit is how do you deal with exceptions, right? And there's two ways to look at it. Maybe we don't want to do exceptions. Maybe we want to write pure functions, or we can say, hey, we can learn from what languages like Scala provide, and maybe there are libraries we can bring in and use it, like Waiver, for example, to mention one. So yes, we can keep reaching into these libraries and we can use it. But if really we care about these other libraries, I would say it's perfectly okay to use these other languages. We don't have to be restricted to Java, because to me, if I'm programming in Java, I can benefit from the features it gives. But if I really want something beyond that, I would rather pick a language that gives me that capability than stick with Java and use a library to bring that fit. And the beauty is this: we can mix and match these languages. I can still write code in Java, still use Java libraries in other languages. So I think we should really be polyglot in the environment. I mean, after all, if the JVM is truly an environment where we can write code in multiple languages, why should we restrict ourselves only to write code in Java, right? There's no reason to do it. So I would say be willing to really expand and use other languages in areas where you think you can benefit. Like I've got a lot of clients actually that have production systems in Java, but a significant part of it is in Kotlin. I was talking to a financial company a couple of days ago, and their VP said, hey, when we go to our site and when you click on this link, that code that's running was written by people who are in your class. So if it works, be proud about it. If it doesn't work, we know who to blame, he said, right? but that's purely a polyglot environment. And the team has decided to embrace that and say, hey, we want to really mix and match these things because we're getting better performance, better benefits, productivity by using these different languages and different libraries. I think we should be open for polyglot rather than trying to force ourselves to a language and then the tools that we can bring into it.
Very good. And then last question, Is there anything else that we haven't talked about that's come to mind that you feel like the audience would benefit from knowing? Yeah, what are your thoughts on just the questions we haven't asked or haven't thought to ask?
Well, I would say, I'm more and more keen in improving quality. How can we as a community develop better quality software? We seem to have this desire to acquire new knowledge, but I always kind of wonder, are we doing a better job at getting better at what we have already acquired? Can we take the time to, create better quality code? Can we create more sustainable pace of development? So anything we can do to not talk about being agile, but really being agile. That's one of the things I've been working on more and more with clients is how can we bring in sustainable development where we can address the economic cost of development, right? So a lot of these questions were definitely about technology, and rightfully so. But I also am beginning to question the economic impact of what we do. What are the consequences of what we do? Can we reduce the cost of development? Can we make this more maintainable? Anything along those lines, I think, are very well worth it as an industry, because I think at the end of the day, technology is great, but we are here to support a business. And anything we can do to make that business more sustainable, I think is a maturity that we need to move towards. And that's what I'm beginning to focus more and more with my clients as well. Not so much about languages and framework, but how can we really give a better result for our customers, our provide a business value. So those are the things I'm beginning to think a little bit more as well.
Very good. So sustainable development, what does that look like on a day-to-day basis in your mind?
Discipline.
Okay. Does that like with testing or with code reviews or with pull requests reviews or what ceremonies?
And more, right? And more. Because yes, code reviews, yes, automated testing, but it really is from the smallest to the biggest, right? So when I'm naming a variable, that's part of it too. But I'm going to put this in production. But what's the cost of putting it in production? Is there a way I can automate that process of putting in production? Is that sustainable? Because once I put in production, does it go up in flames? Or is it something? I was talking to somebody earlier today, and he was saying they would put stuff in production and they would spend the next day or two fixing the mess that it results in. Well, but the question is, why are we costing so much money for a business? Because we haven't, are capable to. And by the way, this is a business where if a production system doesn't work, it can cost hundreds of thousands of dollars every hour of lost business. So that's something to really think about, right? How can we be better, not only writing code, but all the way up to production? What are the things we can do? So I think discipline every step of the way, collaboration. I really still feel that our industry is not doing enough of this. We have this, desire to be left alone. We really need to start collaborating more, and just be a lot more open in critiquing each other, asking questions. So many of us are so shy to ask questions. Why do we need to pretend that we know things? Honestly, there is so much we don't know. And I think we should develop a culture where it's okay not to know things. And so we can then go to learn things we need to learn. I think a lot of these things need to be addressed, I think. I was talking to somebody and they were quiet all along because they did not know the most fundamental thing. And eventually, as we're starting to work, they quietly say, "But what's that?" And that's when you realize they didn't even know the fundamental. But it's okay not to know the fundamental. But the problem is we've created a culture where we kind of, make people bad that they don't know something they're not supposed to know. I think there's so many areas where as a society, we need to really get better at embracing this and be more open to communicate and say, it's okay, I don't know. It's okay, it's not to know, but here we are here to learn. I think we need to really build that culture, I think.
So as practicing software developers, what do you recommend that we do as a group to set this example or prevent this imposter syndrome from setting up in people coming into the industry?
I think if more experienced developers are more willing to openly say that they don't know stuff, I think the junior developers are going to be much more receptive to say, hey, it's okay to say that I don't know. And so we need to really start with that. The second, I think, is to really start collaborating. One of the fears that a lot of us have is, if I sit down and start collaborating with you, what if you get to know how much I don't know? But it should be okay that there are things you know better than I do, and there are things I know better than you do. But at the end of the day, we both are going to come out learning. And so I think one of the nice things I like about user groups or community events is it takes us out of our work area. So we are not in an environment where we are being measured or scrutinized or evaluated. So it's not my boss or my peer evaluating whether I know something or not. I'm here out in a user group, and I can spend my time learning as a community. I think that's a good thing, right? And another thing I would say is, if you look at the number of developers in a region and the number of developers who show up to user groups, what can we do to bring more of these people? If I travel around the world speaking in user groups, and I would see the same group of people in almost all the city when I travel around, which is great. I'm glad they are coming. I'm appreciative, I'm thankful. But I'm wondering about the people who are not showing up, right? So what if you, as a person who goes to a user group, gets into a buddy program, and you say, hey, I'm going to use a Java user group on March, whatever date. I want to bring a friend along, right? And that way you are encouraging the next group of people who are not participating in the community, not being part of a user group, to kind of excite them so they start going to user groups. So the first step is go to user groups. Second step is bring a friend along. People bring their spouses, people bring their children. And I'm very appreciative when they do that, right? When I go speak locally, I'm not even kidding right now. I go to my wife and say, I'm going, and in fact, a couple of weeks ago, I went and spoke in the Denver open source user group. And I went to my wife and said, hey, I'm going to speak in the user group. Would you please come with me? And she's like, sure, I'll be glad to come with you, give you company to go there. But to me, that's important, right? We are humans. We are part of a society. We're part of a family. Bring your family along, and the family gets to know where you're hanging out, what they are doing. My children get excited about these kinds of stuff because they've been to these things with me. And to me, that's the next generation, because as they become adults, they start looking at the community and what they can be part of. And they say, oh, I remember, Dad, I went there with you and I see this one. And that's great, because now they know where to look for it. So I think we can build a community. I think we can build a community as it is now, but we can also build a community for the next generation as well. So bring a friend, but bring a child. I think those two, attack two different angles. And I think we can, build a community by doing that, I think.
Very good. Very good. All right. Well, I think we have to end there, sadly. Thank you so much, Venkat.
Thank you. Thanks.
And thank you, everyone, for sticking around this whole time. I know we're like a half hour over, but I just couldn't bring myself to cut it off. It was such a good discussion. All right. So I will quickly announce the winners of our drawing. We've got 4 prizes. And for these people who won, you don't have to do anything. I will email you with your prizes. So the first prize is for a JetBrains license, and that goes to Rashab Nayak, and I will email your certificate to you. The second one of those goes to Craig Larson. So I'll email you, Craig. And then the Agile Learner, the site that Venkat mentioned there, that goes to Dheeraj Vislawath. So I will loop Venkat in, and you will get your certificate there. And then for Tech Systems $25 gift certificates, the winners are Keith Branton and Richard Hall. So thank you everyone for attending. This recording will be available here on Crowdcast afterwards. And we have a YouTube channel that we'd appreciate your subscription to that. You can just search for UJUG YouTube. And remember, next month we've got Chris Mackey, and the month after that we've got Ian Robertson, and later in the year we got some other great talks. As far as getting back in person, we don't have any plans so far, but we're hoping for the summer. But much like Venkat, we are taking it. We're not making any plans. We're just trying to be flexible. So I appreciate everyone's flexibility, and you can see the accolades coming in the chat right now. So thank you so much, Venkat, and hopefully you can get some sleep today. Sounds like you're getting close to 24 hours.
Thank you. Appreciate it. Thanks for having me, and thanks everyone for joining.
Okay. All right. Goodbye, everyone.